So, hello everyone, this is the first lecture part 1 of a new chapter called as wave optics. As you have already come from ray optics, wave concept of light will be studied in this chapter. So, let us begin our new discussion on wave optics. I am Sameer Lavankar. So, let us get started. So, the course outline, just to start the lecture first. So, we will be covering up first of all the introduction part, as in why there was a need to understand the wave concept of light, why only till ray concept it is not being okay, why a new concept of being imposing it as a wave is required. Then why does the laws which were being studied intact before this, can it be applied if we consider wave also, wave optics also. So, we will understand this discussion, we will go on with this discussion. Moving on, next will be Huon's principle, we will understand who was Huon, what was the principle being incorporated in this. Then the refraction and reflection of plane waves using Huon's principle. So, the concepts you already studied in ray optics, now we will apply the concepts of wave to understand refraction and reflection concepts. Next will be coherent and incoherent addition of waves. What is coherent, what is incoherent, I will explain to you in very detail what are these concepts. Then next will be interference of light waves and Young's experiment. So, Young's experiment, Young was a very prominent scientist. He did some experiments related to interference of waves, the generation of black lines, generation of dark lines and bright lines. What were these experiments, how were these experiments conducted, what was the theory behind these experiments, everything will be talked in detail. Next will be the application part, or the final part of this wave optics will be diffraction, and finally we will concluding the chapter with the concept of polarization. So, for now without any further ado, let us start with the concept of wave optics. What is wave optics? Let us start with the introduction of this chapter. So, let us move on to the introduction part. So, please look over here carefully. So, in 1637 Descartes was also one of the prominent scientists in 17th century era. He gave the corpuscular model of light. So, what is corpuscular model of light? I will explain to you in the next point only. So, he gave the corpuscular model of light and derived Snell's law. What is Snell's law? We will understand in this chapter only. For now, let us look over to only this concept of what is corpuscular model of light. So, corpuscular theory of light was proposed by Descartes in 17th century, as already told you, in 1637. So, what was this theory? This theory was about that light, states that the light is made up of very tiny discrete particles. Please understand the phenomena, please understand the concept here. Descartes pronounced light as consisting of many tiny particles. So, particles, very small particles were being considered, and the complete collection of these were considered as a light. So, that is if we have many discrete particles like this, and if it is moving in a straight line, then we consider that light is moving in a straight line. Light is moving in a straight line. So, the figure on your right also tells the corpuscular theory only. So, as you can see, so these blue dots are nothing but corpuscles. So, a complete collection or complete group of these corpuscles is nothing but a light as devoted or as described by Descartes. So, this was nothing but the concept of corpuscular model of light. So, just iterating it again. So, the corpuscular theory of light states that light is made of tiny discrete particles called as corpuscles. What is corpuscle? Corpuscle is nothing but very tiny particles which travels in a straight line with a finite velocity and possess impetus. Impetus as in any force or body which a particle has is known as impetus. So, this was the basic theory for which initiated the theory of light, which initiated the concepts of light, which initiated the concepts of refraction and reflection. So, as you can also see on the right hand side figure, the concept of law of incidence is equal to law of reflection is being told here. So, incident corpuscles being incident on a reflecting surface and then going in this direction is nothing but showing that the light travels a path of having law of incidence angle of incidence is equal to angle of reflection. So, this was nothing but the corpuscular theory of light. Moving on, so it explained the laws of reflection and refraction of light at an interface. So, the laws which you have already studied in your previous chapters or in previous classes also about laws of reflection, the basic laws of reflection and refraction were being explained using this theory. Which theory? The corpuscular theory of light. Moving on, the corpuscular model predicted that if the ray of light on refraction bent towards the normal, then the speed of light would be greater in the second medium. Please look over this line very carefully, I will explain it with a small diagram also. So, what does this say is, let us say this is the interface, like let be very specific, let this be the interface, let this be the interface, let this be medium 1, let this be medium 2. Let this be the perpendicular, let me change the color for more clarity. Let this be the perpendicular bisector on the interface, and let green color be the color showing the color of light. So, let us say that this is the incident wave here. So, what it is saying is the corpuscular model predicted that if a ray of light on refraction bent towards the normal. So, this blue line is nothing but the normal line. So, if it is bending towards the normal, then that means its direction is like this. So, if the original direction is like this, bending towards the normal means going towards the normal, means attracting towards the normal. So, this is the concept being talked here. So, let us say the velocity in medium 1 is v 1, the velocity in medium 2 is v 2. So, now what does this point say is that when the ray of light is bending towards the normal, the speed of light will be greater in the second medium, that means v 2 is greater than v 1. So, this is the concept being talked about in this corpuscular model of light, but when the wave theory of light came into existence, this thing or this point was being rejected. The actual concept, when we talked of experimental data analysis, it was found that if the wave or if the ray of light bends towards the normal, then the velocity is less than the above medium. How it was being done, what was the theory behind it, we will get to know in subsequent slides. But for now, what does corpuscular model says? Corpuscular theory of light says that if let there be an interface, let there be a medium 1, let there be a medium 2, let there be a normal. So, if an incident wave is passing through it on refraction towards the normal, the corpuscular model of light states that the velocity in the second medium is greater than the velocity in the first medium. So, this was only the point I explained you with a small diagram here. Let us move on, let me change the color again. So, now this corpuscular model of light was further developed by Sir Isaac Newton. Isaac Newton, as you already know, the prominent scientist, the most famous scientist of our era. So, this corpuscular model of light was further developed by Isaac Newton in his famous book entitled Optics. So, this concept was being talked in optics. He further collaborated with Descartes also to further evaluate this study. And because of the tremendous popularity of this book, the corpuscular model is often attributed to Newton. So, as you can also see from the diagram, the complete theory was being made by Descartes, and everything is now related to Newton only. So, everything, the final conclusion was that Newton made this theory. Everything was being done by Descartes, but at finally as the published book was done by Newton, hence the every work which we know was done by Newton. So, this is just an information. So, what we studied from this slide was ki Descartes started the theory of light, which was known as corpuscular theory of light. This corpuscular model states that light is made up of very tiny particles. So, it explained the laws of reflection and refraction, and one of the prominent concepts we got to know from this point was that let there be a refraction from a medium 1 to medium 2. If the medium ray of light enters and bends towards the normal, then the corpuscular model states that the velocity in the second medium is greater than the first medium. So, this was the first slide. Let us move on to the next slide now. So, in 1678, so now after the complete work in 1637 by Descartes, after a few years in the 17th century only, in 1678, the Dutch physicist Christian Huygens. So, he was only the prominent scientist who gave us the Huygens principle. So, in 1678, the Dutch physicist Christian Huygens put forward the wave theory of light. So, this is the complete chapter, this is the complete concept which we will be studying in this chapter. So, he put forward the wave theory of light. It is this wave model of light that we will discuss in this chapter. Let us move on. So, the wave model could satisfactorily explain the phenomena of reflection and refraction. How it will explain, we will get to know in subsequent slides. For now, as it is introductory part only. So, the wave model could satisfactorily explain the phenomena of reflection and refraction. However, it predicted that on refraction, the wave, if the wave bends towards the normal, then the speed of light would be less in the second medium. So, as I already pressurized on the last second point in the previous slide, let me show you the same diagram only. So, if this is the diagram here. So, if we take the corpuscular model of light, let me write it as CML, and if I take you the wave theory of light. So, wave theory of light as WTL, then what does this say is, that the velocity in the second medium is greater than the velocity in the first medium, and this wave theory of light states it opposite, that is wave V2 is less than V1. So, why, like what should be the actual data, what should be the experiment. So, when the experiments were being performed, it was found that the wave theory of light is accurate enough. The corpuscular model of light was being rejected on this part, on the refraction part. So, it is written here also that this is in contradiction to the prediction made by using corpuscular model of light. It was much later confirmed by experiments where it was shown that please look over this point very carefully. It was much later confirmed by experiments where it was shown that the speed of light in water is less than the speed in air, confirming the prediction of the wave model. So, this concept is being talked in this right figure also. So, it is nothing but air is being the first medium, let I denote it by 1, and water being the second medium, let me denote it by 2. If the ray of light is being entered, let this be the normal line as depicted in the slide, depicted in the figure also. Let this be the boundary, boundary is nothing but the interface. So, as you can see that this ray of light is being, after refraction, is bending towards the normal. So, if it is bending towards the normal, according to the corpuscular model of light, the velocity in water, let me write it here, according to corpuscular theory, it states that the velocity in water is greater than velocity in air, but according to the wave theory of light, it was predicted that velocity in water is less than velocity in air. So, when the experiments are being done, so it is written here that it was much later confirmed by experiments where it was shown that the speed of light in water, so speed of light in water is less than the speed of light in air, thus confirming the prediction of the wave model. So, it was finally confirmed that the wave model predicted the refraction concepts also much accurately, much precisely. Hence, wave theory of light was being further studied, and different concepts such as diffraction, polarization, interference, Young's experiment were being performed, and this will be the main agenda of studying this chapter. So, Foucault carried out this experiment. This experiment was carried out by Foucault in 1850. So, you can see the variation also, that the wave theories in the introduction and then being analyzed, these experiments were performed to calculate the accuracy of wave theory. How much difference in year was there? In 1678 the first experiment was being done, and this experiment of being confirming the refraction concept was being done in 1850. So, just to know, just as the introductory chapter, just to know that significance, we try to learn these concepts in just 7 or 8 slides, but actual thing which when it was being performed, it took around 100 to 200 years. So, let us move on to the next slide now. So, the wave theory was not readily accepted primarily because of Newton's authority. So, as Newton was being adamant towards the concept that light cannot be a wave particle, light can only be a wave theory, light can be only a particle theory. So, as he was adamant that my work is correct only, therefore, there was huge resistance on accepting this wave theory. This was being told in the Newton's era, when these experiments, when these prominent scientists were being intact in their work, then Newton tried to resist this wave theory of light. If there was, let us suppose that if there was resistance completely and Newton's authority was being done completely dominated, then maybe no wave optics chapter would have been today. But because when experiments were being performed, we got to know that there was many insights of wave theory of light, and because it was being proved also, there were many proofs for this experiment, hence this authority was being neglected and wave optics upgraded. So, the wave theory was not readily accepted primarily because of Newton's authority and also because light could travel through vacuum, and it was felt that a wave would always require a medium to propagate from one point to other. So, Newton proposed that how can a wave theory of light be, so how can a light be analyzed as a wave, because light can also travel through vacuum, and when it was being proportionalized or when the wave concept came into picture, it was got to know that wave can only pass through if a medium is available. Medium can be an air, medium can be a mode a material of having permeability mu r or mu k. So, anything but wave's major propaganda was that it should have a medium. When this concept was being neglected, so Newton proposed that this cannot be, this wave theory of light cannot be accepted, and hence he tried to reject it. But when further analysis was being done, it was got to know that the medium is not even required. Sometimes the wave can also pass through a vacuum also. How it was being passed, how it was being done, if these things are being required as per 12th syllabus, I will explain to you. But for now, let us suppose that what Newton did was Newton tried to resist this acceptance criteria for wave theory of light. Next, so however, when Thomas Young performed his famous interference experiment, this interference experiment we got to know in the last concepts of this chapter. However, when Thomas Young performed his famous interference experiment in 1801, it was firmly established that light is indeed a wave phenomena. How it is a wave phenomena we will get to know in subsequent slides. For now, let us suppose that Thomas Young performed his famous interference experiment. Next is the wavelength of visible light was measured and found to be extremely small. For example, the wavelength of yellow light is approximately 0.5 micrometers. Just to iterate to you, 1 micrometer is nothing but 10 to the power minus 6 meters. So, as you can actually see how much small the wavelength is. So, the wavelength of yellow light is about 0.5 micrometers. Because of the smallness of the wave of visible light in comparison to the dimensions of typical mirrors and lenses, light can be assumed to approximately travel in straight lines. So, as the dimensions of wavelength were very small, it was being assumed that it can travel in straight lines. So, after the interference experiment of Young in 1801 the experiment was being done. For the next 40 years or so, many experiments were carried out involving the interference and diffraction of light waves. What is interference, what is diffraction, we will get to know in subsequent slides. For now, after this experiment was being done, so it was being proved that light is a wave phenomena, hence more research was being done, and finally the concepts of interference and diffraction came into picture. These experiments could only be satisfactorily explained by assuming a wave model of light. So, what were these experiments we will get to know in subsequent slides. For now, let me stop this lecture here only. In this 2 to 3 slides we got to know the corpuscular model of light, the major agenda, what the refraction concept was being lagged upon in corpuscular model of light, then about the wave theory of light, how the experiments were being performed, how the experiments such as Young's experiment was being performed, when it was performed, what was the age gap between the various experiments by Descartes, then by Newton, then by Young's, then by Huygens, etc. And finally, some of the basic agenda of how the proof of wave theory led to the experiments of interference and diffraction, which can only be understood if we understand that light is a wave phenomena. For now, let me close this lecture here only. So, thank you for now.